Good day, Springford. This is Mrs. Smith. We will be going over Grade 6, Chapter 10, Volume and Surface Area, Lesson 4, Surface Area of Triangular Prisms. Independent practice pages 777 and 778. Find the surface area of each triangular prism. Now, just like with the rectangular prisms, we're going to need to draw each face. So what's unique about a triangular prism is that it has two triangular faces. So we draw those. Now the rest of the faces are actually rectangles. So we have a left rectangle and a right rectangle, and then we have a bottom rectangle. Sometimes they may be the same size, other times they're not. In this case, because our triangle faces are scalene triangles, all of our rectangles are different sizes. They're not congruent. Now, the triangles are going to be congruent. So if we find the surface area of one, then we'll have the surface area of the other. All right, so let's take a look at our first triangle. So area is going to equal 1/2 times the base, and the base is 51, because here we have the base, times 51 yards, times the height, which is indicated by the pink line, which is 12 yards. I'm going to multiply 12 times 1/2 first, and I get 6 yards times 51 yards. And so my area for one of my triangular faces is going to be 306 yards. Now I'm going to multiply that times 2, that's a terrible arrow, times 2, because I have two faces. That's going to give me 612 yards squared for my triangular or triangle faces. Now my left face, which is right here, okay, is a rectangle. So I'm going to do base times height, or length times width. So the width, or the base here, is right here, and that's parallel to this, which is 5. So it's 5 times 37. So I have 5 yards times 37 yards. So my area for the left side is going to equal 185 yards squared. Now my right face, which is also a rectangle, which is right here, has a base of 5 yards times a height of 20 yards, which gives us a total surface area of 100 yards squared. And now our bottom, also a rectangle, is 5 yards by 51 yards. So area equals 5 yards by 51 yards. So our area equals 255 yards squared. Now if I add up all of these surface areas for all of the faces, I'm going to get a total of 1,152 yards squared for the total surface area of the triangular prism. Find the surface area of each triangular prism. Question number 2. So again, we have a triangular prism, which means that it has 2 triangular faces and 3 rectangular faces. Now what makes this triangular prism different than our previous one is that the 2 triangular faces are isosceles triangles. That means that 2 of the sides are the same length. This means that 2 of the rectangular faces are going to be congruent. And then the third one, in this case, will not be congruent. In question number 1, we had a scalene triangle. So all 3 sides were different measurements, which means that all 3 rectangular faces would be different measurements. Here, since 2 of the sides of the triangle are the same, 2 of the faces will be the same, and the third will be different. So that's good for us because that means we have to calculate less. So let's figure out the surface area of the 2 triangular faces. We're going to use the formula 1/2 times the base times the height. So area equals 1/2 times the base, and in this case the base is 1.2 centimeters. 1.2 centimeters times the height, and the height is indicated by the pink dashed line, which is perpendicular to the base, and that is 0.8 centimeters, or 0.8 of a centimeter. So the area equals 1/2 times 1.2 centimeters equals 0.6 centimeters times 0.8 centimeters. So area equals 0.48 centimeters squared. Now I'm going to multiply that by 2 because I have 2 triangular faces, and that's going to give me a total surface area of 96 hundredths centimeter squared. Now for the rectangular prisms, the rectangular faces, I'm going to use area equals base times height. Now these are the faces that are, these are the sides that are congruent, because I see that this is 1 and this is 1. So it's my left and right rectangular faces that are the same. So we have the base is 1.2 centimeters and the height is 1 centimeter. So the area equals 1.2 times 1 is 1.2 centimeters squared. I'm going to multiply that times 2, and that's going to give me 2.4 centimeters squared for my total surface area. Now the last is the bottom of our triangular prism. And the area is the base, which is 1.2 centimeters, times the height, which is also 1.2 centimeters. And this doesn't really look like it would be a square. I don't know. They kind of made it, I don't know if that's just an optical illusion, but they really didn't draw it in a way that made it look like a square, but that should be more square-like because it's the same dimension. But 1.2 times 1.2 is 1.44 centimeters squared. Now there's only one bottom, so that is my total surface area. And when I add up all of the surface areas, I get a combined 4.8 centimeters squared. Question number 3. Find the surface area of each triangular prism. So we have two triangles. We need to be very observant here because while it might look like it's an isosceles triangle, it actually is not. This side right here doesn't have a measurement, but it's actually listed down here as 1.75. So right here, this is 1.75 or 7 meters, and this is 1.5 meters on the right. And then the base is 2.4. So this is a scalene triangle, which means that every rectangular face is actually going to be a different dimension. So we're going to have to calculate the surface area for all three rectangular faces independent of each other. So we're going to have three different faces. All right, so let's start with a triangle though. We have that the area equals 1/2 times the base, which is 2.4 meters, times the height, and the height is 1 meter. So the area is going to equal 1.2 meters times 1 meter. So the area is going to equal 1.2 meters squared. We happen to have two triangular faces, so I'm going to multiply times 2, and that will give me 2.4 meters squared for my total surface area of both triangular faces. Now for the left back, I'm going to use purple, and this is a rectangle right here, and it's going to be base times height. So we have 1.7 area equals 1.7 meters times the height, and the height is right here, and that would be 2 meters. And I know it's 2 meters because right here is 2 meters, and that's parallel to this. So the area equals 3.4 meters squared. And there's only one of them. All right, next we have the right back, and I'm going to use red, and that's right here. And the area is going to be, the base is 1.5 meters times 2 meters. So the area equals 3.0 meters squared. And then the front, I'm trying to indicate in blue, the area equals 2.4 meters times 2 meters. So the area equals 4.8 meters squared. And if we add up all of these, we get a total of 13.6 meters squared. And I had already revealed the answer, but just to confirm, we got the same answer. All right. Question 4. Find the surface area of each triangular prism. When we take a look at this prism, we have two triangular faces. When we look closely, we see that each side of the triangle is a different length. One of the sides is 10 centimeters, the other side is 12, and then the hypotenuse, which is across from the right angle, is 15.6 centimeters. I know that because it's parallel to this side, which is labeled 15.6 centimeters. So this is a scalene triangle, okay? Now one thing we know also, because there's a box here, is that this is a right triangle. This means that the 10 centimeters is going to be the height, and the 12 centimeters will be the base. So we can plug these numbers into our formula. Area equals 1/2 times the base, which is 12 centimeters, times the height, which is 10 centimeters. So area equals 1/2 times 12 is 6 centimeters, times 10 centimeters. So area equals 60 centimeters squared. We have two faces, so I'm going to multiply that times 2, which gives us a total surface area of 120 centimeters squared. Now, this is a scalene triangle, which means that every rectangular face is going to be a different dimension. None of them will be congruent. Let's take a look at the left rectangle. Okay, we see that it's 10 by 11, because this is 11 and this is 11 right here. So the area equals 10 centimeters times 11 centimeters. So area equals 110 centimeters squared. Now we're going to take a look at the bottom rectangle. Okay, so we have area equals, the base is 11 centimeters times 12 centimeters. So the area equals 132 centimeters squared. All right, and then we're going to look at the right face, which is right here. And area equals the base, which is 11 centimeters, times the height, which is 15.6 centimeters. So the area equals, when we multiply those numbers together, we get 171.6 centimeters squared. Now we have to add all of these surface areas up together. And when we do, we get a total surface area of 533.6 centimeters squared. Question number 5. A tent is in the shape of a triangular prism. About how much canvas, including the floor, is used to make the tent. So the front of the tent is a triangle, and the back of the tent is a triangle. If we take a close look here, we can see that this is an equilateral triangle. The base is 1 yard and 1 yard, which adds up to 2 yards. And each side is also 2 yards. This means that each rectangular face is going to be congruent. Let's first figure out the area of the triangles. So the area equals 1/2 times the base, which we said was 2 yards, times the height, which is 1.7 yards. So the area equals 1 yard times 1.7 yards. The area equals 1.7 yards squared. Now I have 2, so I'm going to multiply that times 2, which is 3.4 yards squared. Now, like I said, all of the sides that are rectangles are going to be congruent because the triangles are equilateral. The dimensions of the rectangles are, the base is 3, and the height is 2. So area equals 3 yards times 2 yards. So the area equals 6 yards squared. Now we're going to multiply that times 3 because we have 3 rectangles, which gives us 18 yards. We can add 18 yards plus 3.4 yards, and that gives us a total surface area of 21.4 yards squared. A decorative gift box is in the shape of a triangular prism as shown. What is the surface area of the box? We have 2 triangles, top and bottom, and when we take a close look, we see that the triangles are scalene triangles. That means that each side is a different length. We have 7.5 inches by 10 inches by 12 inches, by 12.5 inches. We have a right angle here, so this means that the 10-inch side can serve as the height, and the 7.5-inch side can serve as the base. This also tells me that each rectangle is going to have its own dimensions and be a different size. None of the rectangles are going to be congruent. We have a left, a right, and a front, and they're all going to be different sizes. All right, so let's start by figuring out the area of the triangles. Area equals 1/2 times the base, which is 7.5 inches, times the height, which is 10 inches. I'm going to multiply 10 by 1/2 because I can do that mentally, which is 5 inches, times 7.5 inches. And then area will equal 5 times 7.5 is 37.5 inches squared. I have 2 triangular faces, so I'm going to multiply this times 2, which gives me 75 inches squared for my total surface area for my triangular faces. Now let's take a look at the left side of our box. Now I can't really see the left side because it's a solid box here, but I know that these are the 2 sides of the left side of this triangular prism. So I have a base of 5 inches and a height of 12.5 inches. When I multiply those 2 numbers together, I get 62.5 inches squared. Now let's take a look at the right side. Area equals, again, the base is 5 inches and the height is going to be 10 inches, a little shorter. So the area equals 50 inches squared. And now we're going to look at the front of the box. Again, the base is 5 inches times 7.5 inches. And when I multiply those 2 numbers together, I get 37.5 inches squared. Now I have to add up all of my surface areas together. Okay. And when I do that, I get 225 inches squared. Question number 7. A mailer for posters is a triangular prism as shown. Find the surface area of the mailer. So here we have our mailer and it has 2 triangular faces. And when we look carefully, we can see that this is, in fact, an isosceles triangle. All right, one side, one green side is 4.7 and the other is also 4.7. It's labeled way back here, but it's still 4.7. What this means is that the left and right sides are going to be congruent. 2 of the 3 rectangles are going to be congruent. And in this case, for our picture here, it's going to be the left and right sides. The bottom is going to be a different size, which is helpful because it's a little bit less calculation that we have to do. So let's solve for the area of the triangles. So area equals 1/2 times the base, which is 5 inches, times the height, which is 4 inches. So I'm going to multiply 4 times 1/2 first, which is 2 inches, times 5 inches. So area equals 10 inches squared. I have 2 triangles, so I'm going to multiply this times 2, which gives me a total surface area of 20 inches squared for the triangles. Now let's figure out the surface area for the left and right rectangles. So area is going to equal, I should change my color here, sorry about that. We're going to do this blue rectangle here. And there's an identical one on the other side. Okay, so area will equal, the base is 18 inches times the height, which is 4.7 inches. So my area equals 84.6 inches squared. And I have two rectangles, so I'm going to multiply that times 2, which gives me a total surface area of 169.2 inches squared. All right, now for the bottom of our container. Okay, so I can't see the whole bottom, but I can see here, and I'm going to overlay, okay, right there. All right, so for our bottom, we have the area. The base again is 18 inches, and the height is going to be 5 inches. So the area equals 90 inches squared. All right, and now we can add up all of our surface areas to get a combined and total surface area for the whole box. When we do this, we get 279.2 inches squared. Question 8. Multiple representations. The figure shows the dimensions of a triangular prism. Part A, models. Draw a model of the faces and bases of the triangular prism. So in this situation, they want us to draw all of the sides or the faces and label the dimensions or the lengths of each side. So for example, we have the front triangle and the back triangle, the right rectangle, the left rectangle, and the bottom rectangle. B. Words. Describe the triangular prism. Here's a sample answer. The prism has right triangle bases, each with an area of 24 feet squared. The rectangular faces have an area of 72 feet squared, 120 feet squared, and 96 feet squared. The total surface area is 336 feet squared. Question C, numbers. Find the surface area of the triangular prism using addition. 24 plus 24 plus 72 plus 120 plus 96 equals 336. So the answer is 336 feet squared. Question number 9. The surface area of a right triangular prism is 228 square inches. The base is a right triangle with a base height of 6 inches and a base length of 8 inches. The length of the third side of the base is 10 inches. Find the height of the prism. Okay, so now I am going to find my pen, and all right, so I have a right triangular prism. So that means I'm going to draw a right triangle. And then I'm going to draw another right triangle. Try to make them as identical as possible. Top to top, bottom to bottom, right to right. Okay, so there's my triangle. Okay. And here is my little, you know, I can actually make this like a little dotted line. Oops, no I can't. All right, maybe I can go like this. Because it's supposed to be like a hidden line, you know. And then I'm going to do that back here too, because these should be like hidden. Okay. All right, there we go. Alrighty then, now I'm going to switch colors to label what I know. Alright, so I know that it is 228 square inches. That's the total surface area. I'm just going to save that information for later. The base is a right triangle. Okay, we did that. The base height is 6 inches. And the base length is 8 inches. All right, so the base height is 6 inches. That's 6 inches, because we're going to say that this is the height. And the base length is 8 inches. And the third side of the base is 10 inches. So that's going to be across from, this is actually the side across from the right angle is the hypotenuse. So that's 10 inches right there. Okay, so find the height of the prism, which is right here. This is what we want to know. All right, so let's find the area of this first triangle. So area equals 1/2 times the base times the height. So area equals 1/2 times 8 inches times 6 inches. So area equals 4 inches times 6 inches. So area equals 24 inches squared. So that's for one of the triangles. We're going to multiply that times 2 because we have 2 triangles, and that's going to give us 48 inches squared. All right, and I know that I have 228, so I'm going to subtract that to see where we are so far. So subtract 48. 8 subtract 8 is 0. Going to borrow, and that's 8, and then I have a 1. Okay, so now I have a 1. So now I have 3 sides, and I have to find the height of the prism. Okay. Okay, now I'm going to do a little bit of algebra here. Okay, so I had 3 rectangles. Okay, so I have rectangle, let's say rectangle, well, I have a left rectangle plus a right rectangle plus a bottom rectangle. Okay, and their areas, oh, they said bottom, sorry, B. And their areas have to add up to 180. Now, they're all rectangles, so their formulas are all going to be the same. Okay. Their formulas are going to be base times height. Now, they all have the same height, which is what's missing. Okay, they all have the same height, which is what's missing. So I'm going to have H for each one of these. Okay? Now, the one on the left is 6 times h. The one on the right is 10 times h. And the one on the bottom is 8 times h. Now, if you can think back to the distributive property, we can undistribute this, which is a made-up word, but it means to factor it out. So I'm going to take the h out of each of these. Okay, and I can do that. I can take this h out, I can take this h out, I can take this h out. Okay, so when I do that, I'm going to have the h here, and I'm going to have 6 plus 10 plus 8. I mean, I took it out, but I put it in front, equals 180. So h times the sum of this, okay? So 6 plus 10 plus 8, so that's 16 plus 8 equals 128. Sorry, I'm not thinking right. 16 plus 8 equals 24. Sorry, I don't know. I was not thinking right. Let me erase that. Eraser and pen. 24. All right, equals 180. Now we're going to divide by 24 and divide by 24. That cancels each other out, and h equals 180 divided by 24 equals 7.5. So the height equals 7.5 inches. Boys and girls, for question number 10, there are many different answers, so I'm just going to tell you one of the answers that they suggest. The question is, describe the dimensions of a triangular prism that has a surface area between 550 square inches and 700 square inches. So one answer that you could have would be a triangular base that measures 9 inches, 12 inches, and 15 inches, and a height of 14 inches. But you could have different measurements, and that's okay. Question 11. Persevere with problems. Sketch and label 2 triangular prisms such that one has a greater volume and the other has a greater surface area. For example, prism A could have bases that are right triangles that measure 3 by 4 by 5 with a height of 1. Prism B with bases that are right triangles that measure 1 by 1 by 1.4 with a height of 10. Prism A has a greater volume while prism B has a greater surface area. Question 12. Justify conclusions. Gary is painting a decorative box with the dimensions shown at the right. A can of paint covers about 25 square feet. Does he have enough to paint the rectangular faces of his box with 3 coats of paint? Justify your answer. Yes. The area of the rectangular faces is about 1.7 feet squared. 3 coats would need to cover 5.1 feet squared, which is much less than the 25 feet squared. And this brings us to the conclusion of our lesson today, hoping you find a little joy in each day. This is Mrs. Smith signing off.